Okay, welcome everyone to my first presentation of the semester. My name is Ryan Kasiba, and we're going to be talking about sports analytics, specifically in the domain of the National Football League. So my topic is going to be forecasting the weekly performance of NFL players. Problem statement is that there's a high variance or variability in players' performance week by week. So there could be a player who consistently plays well week by week, and other players do not. And there could be a variety of external factors which are impacting those performances, like their teammates' performance, or the weather, or their opponent, etc. My hypothesis is that by leveraging historical player performance data as a target variable as well as a feature, rolled up and aggregated, we can essentially forecast a player's expected performance in the future, leveraging other independent variables such as teammate performance, opponent performance, location, home versus away, weather, and other things. So that's the main hypothesis. I do have a stretch goal that I'd like to study, which would be the correlation between a player's Twitter data and their weekly performance. I'd like to take a look at the frequency of their use, the number of their followers, topic analysis, sentiment analysis, and other features that may be indicative of their performance. So there's a lot of data here. This is Davante Adams. He's a wide receiver, and the one thing I want you to focus on is his offensive grades, which I've highlighted there in red. So as you can see here by row, we're looking at his weekly performance grades via Pro Football Focus. So as you can see, in week 1, he had a grade of 80. In week 8, he had a grade of 90.4, and so on and so forth. The example I wanted to use here was week 11, where you can see he got a grade of 87.1. So Davante Adams relies on a quarterback to get him the ball, specifically Aaron Rodgers, his quarterback. He's a very good quarterback. But the quarterback has to play well, or I hypothesize that the quarterback must play well in order for Davante to play well. So as you can see here in week 11, Aaron Rodgers had an offensive grade of 91.2, his best grade of the season. So if you look at Davante Adams' performance, there seems to be a correlation between how well he performed and how well Davante performed, which makes sense. Other features we can use would be the team's holistic performance. So Green Bay as a team, which those two players play for, offensively, how are they playing as a group? Are they blocking well? Are they running well? Are they all catching well? As a group, essentially, we can use those collective features in order to help predict Davante Adams' performance in the future or the next game. And on the inverse, you can look at their opponents. So here's Seattle, and you can look at Seattle's team defense. You can look at how well are they tackling, pass rush, coverage. So if Seattle is playing really well, you would expect that the offensive players on Green Bay to not play as well because they're combating them, right? And just to kind of sum all of that up, the idea is to look at potentially all the players previous week, the last 6 weeks, and then the last 12 weeks, and the variation or the variability between those performances as features. So that's kind of where I'm starting now, but it could change. So here's some Twitter data. Basically, this is Davante Adams. It's the same player. He has 2 tweets that basically he's talking about feeling blessed and being thankful for his talents. And then the second tweet being, his mentality and how he approaches the game and why it allows him to kind of play better. So there's a few cool things that you can do with text that we could use as features. One would be the TF-IDF ratio, term frequency over inverse document frequency. Basically, the term frequency is how often that term is in that document or tweet. And the inverse document frequency is how common or how rare, on the other side, is that term in a collection or a corpus of tweets or all of those documents. So you can use that ratio in order to come up with a probability of, if I take this word, what's the probability of taking this word out of any document, right? Another thing you can do is topic modeling. So if you know how many topics you've seen in your data by analyzing it, then you can say, based on these topics, I want to look at all of these tweets or documents and output me a distribution of those topics. So this tweet is 60% about football and 40% about feeling blessed or whatever it is. So we would need to take a look at those topics. We would need to take a look at the term frequencies in order to do something like that. So it's a little bit more work. And I'm sorry, I'm blocking out the green box here, but basically it just says, we can use those as additional features for our modeling. Real quick, my data sources. So Pro Football Focus, they're actually an organization that grades players week by week. And it's a pretty rigorous process. It's cool. I will share the documentation with you guys if you're interested in taking a look at what those guys do. But I've been in contact with them. They are interested in my project, so that's cool. Twitter, pretty self-explanatory. The tools that I'll be using explicitly, just Python mostly, and then Tableau for visualization. Some of the libraries that I will be leveraging would be Beautiful Soup for parsing HTML if necessary, Pandas for data manipulation, Tweepy for pulling data directly from Twitter, NumPy, Matplotlib for doing various visualizations throughout the process, and then sklearn for doing my modeling at the end. So thank you so much, guys, for watching the video. I look forward to your feedback and watching the rest of your guys' videos as well. So good luck this semester, and thank you so much.